So, a friend of mine, who I will not name in order to avoid embarrassment, recently was a little confused by a physics problem that I'm sure actually a lot of people would misunderstand, and I actually, during the test, misunderstood it, and then I looked at it after and was like, wow, how did I even get a 5 on my AB test? But it's actually just derivatives and slopes, and so it's actually quite simple once you get down to the gist of it. But the basic idea of it was there is a kid. Okay, so I'm gonna try my best to draw a kid. Well, let me just draw a stick figure. He draws a ball. Okay, let's say like 5 seconds later, he catches it at the original position, and the question just simply asks you to sketch a velocity versus time graph and an acceleration versus time graph. And a key thing to note here is that position versus time is the antiderivative of velocity versus time, which is the antiderivative of acceleration versus time. So that's why I put primes here, because f of x would be position, f prime of x would be velocity, f double prime of x would be acceleration. So simply here, we could kind of just view it as that. And a key thing to note is it's not that he catches it over there, it's that he just throws it up and comes back down. He catches it at the same exact y height. So it just asks you the velocity of it. Well, as you see here, the ball is obviously going up, but what is happening as the ball is going up? Well, we know g is 10 meters a second. Now, what is g? G is simply the gravitational pull of the earth, and well, it's negative g here because it's pulling us down to the earth, so negative 10 meters a second squared. And we know when acceleration is negative and velocity is positive, that the object is slowing down. It is slowing down. And same thing would be if velocity was negative and acceleration was positive. If the signs are not equal, they are slowing down for acceleration and velocity. So here the ball is positively going in a positive velocity upwards, but the acceleration is negative. So it's slowing down. And it started from a height that is not 0. So let's say it started at like 5m. Let's pretend that is 5. Just pretend it's a certain height. Okay, well, since it's slowing down, it has a negative slope. Eventually, it reaches its max height as before it turns around and comes back down to his hand. Well, at this max height, his velocity has to be 0, because then it turns around and comes back down. So velocity hits 0. Let's go ahead and negative to that. So now it's going back down, and this time the velocity is negative, and the acceleration is negative. So we can go ahead and say that the object is speeding up or velocity is moving away from 0. That'll be velocity versus time. And another way to think of it too is, since we know that delta x, or displacement, is 0, and we know that we can calculate delta x through the integral of velocity graph, that if this was per se 5, this was 2, and this was negative 2, let's say that, we would know that this is negative 10, as these are both the same area. And what's 10 minus 10? Well, that is simply 0. So the area here and the area here, or the integral from 0 to the time he catches it, is simply 0. So I'm just making up numbers, because I don't quite remember the numbers used in the actual question. But now we're gonna go ahead and sketch the slope for this. And why, you say? Well, because we're gonna sketch the slope of this because it's simply f prime of x of f prime of x, or f double prime of x. So it's a derivative. And what is a derivative? A slope. So here we reach 0 here. That's where it makes a jump. So here it's negative, hits 0, and then it's negative again. So that's what it's going to be. The 0 didn't matter. I don't know why I even pointed that out, but this slope the whole time is negative. And also, if you recall, this here, the acceleration or the pull of gravity from Earth, is always negative 10. So this is always negative 10. That is our velocity and acceleration graphs. Go ahead and say that's negative 10. It's not negative 10, but the AP Physics board has us use that as it is simpler to calculate than, like, I think it's like negative 9.8 something meters a second squared. But yeah, that's the gist of all this. So hopefully you learned a little something, and yeah, have a good day.